Okay, for the next thing we're going to go over this weird thing that it always does on the independent sample t-test, this Levene's test for equality of variance. And for those that are listening in, I'm going to make this very simple and give you the answer first, and then we'll go back to it. If you look for the Levene's test for equality of variance, where it says sig, if sig is 0.05 or greater, you use the top line, equal variance is assumed. If sig is less than 0.05, use the bottom line. That's all you'll need to know at the end of this. But I do need to give you the little bit of a story here. And the story is under B, understanding SPSS and the printout. So the example I want to give you here to teach you about this one time is, let's say, if you look at 2A here, let's say I had a data set, two data sets. Let's say I had one group where the numbers were 1, 2, and 3. Right? Pretty easy data set. And let's say I had the other group where the numbers were 1, 2, and 3 billion. Can you picture that? So, if you turn your book to page 317, if you look at that picture, we have two samples here. 1, 2, and 3, and 1, 2, and 3 billion, right? Now, those are both samples, sample A and sample B. We assume, if we get two samples, that the populations that they come from are similar, that the dispersion in the populations, the variance in the populations are similar. We assume that normally. Now, if I have 1, 2, and 3 and 1, 2, and 3 billion, can we assume the populations are similar? No. If you were to actually draw it, or even look in that, you'd probably have 1, 2, and 3 with just a little normal curve, and 1, 2, and 3 billion would be just huge. If you have that situation, you would have a problem with something that is called equality of variances. The 1, 2, and 3 billion and 1, 2, and 3, you would be violating this idea that as part of the independent t-test, the variances of the population are equal. And so what happens here is SPSS actually does a test for that. It does a test for that, and the name of the test is called what?
Levene's test.
It's called Levene's test for equality of variances of the population. And so the idea is Levene's test, if there's a Levene's test and the result is non-significant, and in this case we have very similar data sets, right? Similar dispersion. If the sig value is greater than 0.05, you can assume the population variances are the same. And then guess which line you can use?
The equal variance.
The equal variance is assumed. If the significance is less than 0.05, then it'll test for that, and then you can't assume that, and you simply use the bottom line. So I wanted to use the 1, 2, and 3 and 1, 2, 3 billion because it illustrates from the picture on 317 how the populations are very different there, and if they are, Levene's will actually correct for that, and SPSS will, but that's a test that's done. Does that?
Yeah, I always wondered.
So the take-home message for the Levene's test is if sig is greater than 0.05, use the top line because the population variances are equal, and if it is less than 0.05, then you have to use the bottom line. This is not a test for significance. This is a test of equality of variances. It's actually called homogeneity of variance. Okay, so that's that one.